Today we're going to graph quadratic equations. The basic quadratic equation is the equation y equals x squared. We can obtain its graph by plugging in values for x into the equation and getting out values for y and then plotting them on the graph. For example, if x is negative 3, y is going to be negative 3 squared, which will give me 9. So negative 3, 9 is going to be one of our points. Similarly, we can fill out the table of values and then plot these points on the graph. Once we join up the points, we form what's called the graph of y equals x squared, which is called a parabola. There are some features of this parabola, of any parabola, that we need to look at. The first thing you want to look at when you see a parabola is what we call the vertex of the parabola. The vertex is the lowest point or highest point. In this case, the vertex has a coordinate 0, 0. It's the origin for the basic graph of y equals x squared. As we graph more quadratic equations, which will give us parabolas, we'll see that we also need to look for x-intercepts. So let's look at some more quadratic equations and their graphs, which are parabolas. In general, the graph of the quadratic equation y equals ax squared, where a is the lead coefficient, is a parabola. And if a is positive, the parabola is going to open up, and the vertex is going to be at the origin, right at the bottom. So the vertex would be the lowest point if a is positive. If a is negative, if a is less than 0, the vertex is going to be at the top. So that's going to be the highest point, or the maximum. It's still at the origin, 0, 0. But the parabola will now open down. For example, if I want to graph y equals 2x squared, 2 is the a is positive, 2 is positive, so it's going to open up, vertex at the origin, 0, 0. Let's look at some of these points. The point 1, 2 is on the graph because if I plug in 1 for x, I square it, I get 1, and then times it by 2, I get this 2, which is the y value. Similarly with 2, if I plug 2 in for x, you square it, you get 4, and 4 times 2 is 8. And that happens on the negative side too. So this is a graph of 2x squared. And this is the graph of y equals negative 2x squared. So now with a negative, where a is negative, negative 2 in this case, it's going to open downwards. The vertex is still at the origin. But the points are now, here we have negative 1, negative 2. Sorry, 1, negative 2. 1 squared is 1 times negative 2 gives me negative 2. Here we have negative 1, negative 2. Negative 1 squared is 1 times negative 2 gives me negative 2. And so on. So this is the graph. If a is negative, it's going to open downwards. Now what happens if you start to add and subtract here to the x squared? Well, that might change things a little bit. So in general, when you want to graph a quadratic equation in two variables, where y equals ax squared plus bx plus c, there are two things you need to find in order to graph it. If it were just ax squared, we've seen that's pretty easy and the vertex is at the origin. However, when we add a stuff here to the ax squared, it's going to change that. But the first thing we do want to find is the vertex. We find the vertex. And why? Because the vertex is the lowest or highest point of the graph and indicates a vertical line of symmetry. So for example, here in this parabola here, the vertex is at the origin, which indicates y equals 0, x equals 0 is a line of symmetry. In other words, the y-axis is a line of symmetry. And so, why is that line of symmetry significant? Because of the second part to graphing a parabola is step 2, find the x-intercepts. The x-intercepts are equidistant from the line of symmetry. And so that allows us to complete the picture. In other words, here we have a parabola, and the vertex is down here, and so the line of symmetry, in this case, is the y-axis again, and there's the two x-intercepts. These two x-intercepts are equidistant. This distance here and this distance there are the same from that line of symmetry. And so by knowing the vertex, and by knowing the x-intercepts, we can sketch a graph of that quadratic equation. So let's take some examples. So we want to make a graph of y equals x squared minus 4. and we're going to take several steps to do that. We can create a table of values, but we can see on inspection, the first thing is that a is 1. So a is positive, a is 1, that's the number in front of x squared. So it's going to open up. So we know it opens up. The parabola is going to open up. The second thing is you might want to know the vertex. And in this particular equation, it's quite easy to find the vertex because we can see that this is x squared minus 4. And what does minus 4 mean here? It actually means I'm dropping down the vertex 4. The original vertex of x squared was 0, 0. So this means this negative 4 is going to drop down the vertex to negative 4. So there's my starting point. My lowest point, because it opens up, is right here at 0, negative 4. So that's my vertex. The next step is to find the x-intercepts. To find the x-intercepts, you have to set y equal to 0. So if we want to find x-intercepts, we have to let y equal 0. In other words, we're going to solve 0 equals x squared minus 4. If we solve 0 equals x squared minus 4, let's solve this. Add 4 to both sides, we get x squared equals 4. And so, square rooting both sides, we have x equal plus or minus 2. So those are my x-intercepts. X equals plus or minus 2. So that means I have an x-intercept here, and I have one here. Now you can plug in some more points into the equation and have the following graph. So we plug in some points, negative 1, I plug in here, negative 1 squared is 1 minus 4 is minus 3, so we get the point negative 1, negative 3, 1, negative 3, negative 2, 0, and 2, 0, those are the x-intercepts here. The vertex, I didn't write that one, but that's 0, negative 4, the vertex here. And then we plugged in some more, negative 3, 5, and 3, 5. To get a bigger picture of the graph, to get a more accurate graph of this parabola y equals x squared minus 4.